Here is the question from the solid state. Okay, what the question is: aluminum metal crystallized in a cubic structure in which the age of the unit cell is 405 picometer, 405 picometer. Determine the type of unit cell if the density of aluminum is 2.7 gram per centimeter cube. What are the parameters given here? Just look at here. So this is the parameter, one of the parameter. What is the parameter? S of the unit cell, that is what we call S length. Here is given S length, I write here A. So what is the LS in here? 405 picometer. So this picometer, now here another density of the aluminum here is 2.7 gram per centimeter. Density D, I write here, density D, I write here, D is equal to 2.7 gram per centimeter. Now this is the picometer, this is centimeter, so this unit of distance, okay, it must be same, so we convert it into the centimeter. Now here 1 picometer is equal to 10 to the power minus 10 centimeter. You remember this one, okay? Then now from these two parameters, okay, how do we calculate the types of the unit cell? Remember types of the unit cell. So when we discuss about the types of unit cell, types of unit cell we can determine from the number of atoms. Number of atoms per unit cell. So here I write this K, I write by the symbol, that is J. So this number of atoms per unit cell, when we calculate in different types of the unit cell, so this number of atoms can have a 1 and can have a 2 and can have a 4. So when this number of atoms per unit cell K is equal to 1, what is the type of the unit cell? So that is, we write a simple unit cell. And when we have the Z value is 2, that is what we call BCC, that is full form is the body center, okay, close packing. And when the number of atoms per unit cell comes out 4, so what will be the our types of the unit cell? That is the face center unit cell. Inside we write it FCC. Now here we are going to calculate the number of atoms per unit cell from the given dimensional parameter. Now here, so let's we do the calculation. How do we calculate? So we have the formula. What is the formula? So that is the density formula. So in direct, okay, I just write the density formula by the relation. So what is the relation of the density? So from this dimensional parameter, density is equal to, D is the density is equal to, so this is the number of atoms per unit cell multiplied by the molar mass of the aluminum metals divided by volume of the unit cell multiplied by Avogadro's number. Now what is the Avogadro's number? So I think you remember 6.022 into 10 to the power 23, that is the per mole. And one more, what is the molar mass of the aluminum? As you know, molar mass of aluminum, that is the 27 grams per mole. So we know this, and so density is given here, as length is given here. So we need to calculate the Z value. How to calculate the Z value? So Z is equal to, we cross multiply here, D cube into Na divided by some molar mass. Now here, what is the density here? Okay, 2.7 gram per centimeter cube multiplied by, what is the A is here, so it's already converted into a centimeter, so it should be the cube, so I write a cube multiplied by 10 to the power minus 10, that also be cube. And now one more here, so I remove this part. So here is centimeter, so this centimeter also we have to write it 3 times, that is centimeter cube. And one more is the Avogadro's number, I write here Avogadro's number 6.022 into 10 to the power 23 per moles, and divided by, so what is the molar mass of the aluminum? That is the 27 grams per mole. When we do the calculation, so this number of atoms per unit cell, no unit, so the units These are present here. We can cancel this per mole cancel, and this gram can be cancelled, and this centimeter per cube and this centimeter cube can be also be cancelled. No more units remain. So answer will be no unit. And when do we calculate? So 405 multiplied 3 times. When do we multiply it here? So we found it is much big value. So this big value we just convert it into the scientific notation along with the only 3 significant figure. So when we bring this decimal place from here up to the 7th place, when we bring up to here, that is the 7th place, we move on the left side. So when we move on the left side, this 10 to the power should be plus. So I write the 10 to the power 7. So now I just took only the 3 significant figure up to this. So all these things are rounding up. So we found only the 6.64. So now when we do this 6.64, now just without a calculation, I just show you. So I remove these things. Now here, so what is the remaining? Z is equal to, so what is it? 2.7 into, so when we do calculate, so we found a 6.64 into what, the 10 to the power, this is 10 to the power minus, okay, all these there, 10 to the power 7 and into 10 to the power minus 10 whole cube, that means 10 to the power minus 30 and into then 6.022 into 10 to the power what is remain there, 10 to the power 23, no units remain, divided by so 27. So now here this is the positive, okay, exponent, this is also positive exponent, so 10 to the power 7, 10 to the power 27, that when you the plus, that is 10 to the power 30, this is minus 30, this is plus 30. So all these threes can be cancelled. So what are remain here? 2.7 into 6.64 into 6.022 when we do calculate. So 27, what will be the answer? That, so when we do the calculation of these 3 multiplication, so we found it 107.96, I think approximately we can find, then 27. So when we divided 107.96 divided by 27, the approximately we can find 3.99. So this is the value of the Z. But in our types of the unit cells, we have only 3 values. One is 1, another is the 2, another is the 4. So this 3.99 is approximately close to the 4. So here the Z value comes out of 4. If Z value comes out 4, what should be the types of the unit cell? The types of the unit cell is, so we can write as before I given to you, what was, that is the FCC. So this is the answer of that question. Okay, you remember? So we can pick up the another question also. Yes, here is the another question. Okay, so here what the question is, from the given dimensional parameters, so we are going to calculate the number of atoms present in the given mass of the element. So what the dimensional parameters given here? Number 1, cell age means S length is given and density is given. So from this given parameter, how do we calculate the number of atoms present in the given mass? So we have a 2 approach. One approach here is, first we have to calculate, so what are we going to calculate from the given density and S length? What is the formula? Formula is here, density is equal to Z into molar mass divided by volume of the unit cell multiplied by Avogadro's number. Now here, so this element has a BCC structure. So in BC structure, this Z, what is the Z? Z is the number of atoms per unit cell. What is the value of the Z? That is the 2 for BCC. Number 1 we found here. And number 2, so density is given here. What is the density is given here? That is the 7.2 gram per centimeter cube. And what is the S length is given here? S length A is the given here 288 picometer. But remember the density, the unit is given here gram per centimeter cube. So here the S length is picometer. So I think better to calculate in centimeter. This picometer we have to convert it into the centimeter. So 1 picometer is equal to 10 to the power minus 10 centimeter. So I just converted 288 into 10 to the power minus 10 centimeter. So now we convert it in centimeter. And now density we have, and S length we have, Z values we have, and the Avogadro's number, I think we know that is Avogadro's number is 6.022 into 10 to the power 23 per mole. Now here one thing is left here, this is the mass, molar mass. This molar mass, so we don't know. So if we know the molar mass of any element, if you know the molar mass of any element, we can calculate the number of atoms present in it from the concept. What is the name of the concept? That is the mole concept. Mole concept. What is the mole concept? I write here. So number of atoms present in mass of 1 mole of element. So now here the mass of 1 mole of element, that is we consider as the molar mass. So in 1 mole of the element, the mass, what I just write in the mass of 1 mole of element. So mole is the number. So how many numbers is represented here? How many number? So that is the 6.022 into 10 to the power 23 numbers. So what the number? Number of atoms. This is the from the mole concept. So in our mole concept, we are going to find out the number of particles in 1 mole. In 1 mole, the number of particles or number of atoms, if I consider number of atoms, so that is the number what I just write here. That's what we call Avogadro's constant. So now one more case here. So 1 mole of the element, this is the collective number. This number of the moles, so 1 mole of the element, what the mass we call the molar mass. So if you know the molar mass from this calculation, we could find out the number of atoms for the given molar mass, that is this number. Then here the mass of the element is given here. What is the mass of the element here? 208. So now here, so we can calculate number of atoms present in mass of, what is the mass? What is the mass? 208 gram of the element. What is the element? So we don't know what is the element. So how do we calculate? 6.022 into 10 to the power 23. So that is the atoms, what we write, divided by molar mass. We can put here molar mass after we calculate. So we can find the molar mass. Then now multiply by 208. So 208. So gram, this gram also can be cancelled. So this number should be remain what we found as the number. So this is the way. So I show you how do we calculate. Now here how do we calculate? So we are going to calculate the molar mass. Now here molar mass, from this here relation we are going to calculate molar mass. Molar mass is equal to D into A cube into Na divided by, so what should be we divided? That is the Z. Now what is the D? Just is written here 7.2. That is the gram per centimeter cube, and into A cube, how much A cube? That is the 288, and it should be the cube multiplied by the 10 to the power minus 10, that also be whole bracket 3, and what is centimeter? That also we multiply 3, and let me remove all these things. And what will be the remainder? That is 6.022 into 10 to the power 23. This is the per mole, and will be divided by this Z. What is the value of Z? Here is the 2. So now some of the unit can be cancelled. What unit can be cancelled? This one can be cancelled. So what will the units remain? Grams per mole. So when we do the calculation, the answer will be the grams per mole. So when we do calculation, see, as I said before, when we do multiply this 288, 288, 288, no, when we do calculate, so we'll find a big number. So for the big numbers we could find, that is the 2, 3, 8, 8, 7, 8, 7 to these numbers, big values we found. So for our convenience, let we just make it scientific notation and the minimum significant figure. So I just took the minimum significant figure up to the 3. Now we can rounding about this thing, and decimal place we can bring here. Okay, how many times we just bring? That is 7 times. So that means 2.3. So, and when we rounding about this value, so I think will be some we add some one unit. 2 when we rounding up, it should be remain 7. When we rounding up 7, should be 9. When we rounding up 9, should be 8. When we rounding up 8, should be 9. And when we rounding up, this should be 9. So that means I write 2.39 into 10 to the power 7. Now here 10 to the power 7, 10 to the power 23, that will be the 30. And when we do this, 10 to the power minus 30 to the power 3, that means 10 to the power minus 30, then this can be cancelled. And what will be the remain here? So this 7.2 will be remain into, and we just took a 2.39, then into, then 6.022 will be remain, and divided by 2. So when we do the calculation, so what is the molar mass of the elements we found? That is the 51.8 grams per mole we found. This is the molar mass. After we found the molar mass, so after we found the molar mass, as I said before, so we apply the mole concept. What is the mole concept? So as I said, mole concept, by mole concept. For the mole concept here, so I write a number of atoms present. So what is the molar mass here? Present in 51.8 grams per mole of element. So how much present? That will be the same with the Avogadro's number, 0.022 into 10 to the power 23. So that is the atoms. Now we are going to find out from the given gram, how much gram is given here. So we can do like this: number of atoms present in, how much gram is given here? 208 gram of the elements. Now here the very simple calculation here, we can do 6.022 into 10 to the power 23 and divided by 51.8. Now here is gram per mole. Okay, and this also atom per mole, right? So per mole can be cancelled, and what will remain here? This 208 gram. This 208 gram can be cancelled, and when we do the calculation, so what answers found here? That is 24.16 into 10 to the power 23 atoms. So this is the answer for that question. Okay, you remember it. Okay, here is another question. Okay, the dimension parameters as we discussed earlier. So it's saying it that. Okay, so now here the question is niobium crystallized in BCC structure. Density is given here. So now another question is how to calculate the atomic radius of niobium. So atomic mass is given here. So now here, so how to calculate? I just give you the first hints. So here niobium crystallized in a BCC structure. When we are talking about the BCC, so I think you remember the number of atoms per unit cell, that is the Z. What is the Z value? That is the 2. Number 1, you remember it. Number 2, so in BCC, so one is density is given. So from the given density, so from the given density, what was the relation, what was the formula of the density from the given crystal's dimensional parameter? So that is the D is equal to, what is it? That is the Z into molar mass divided by KAQ into, that is Avogadro's number. So this is the one of the approach. That means we have this types of the formula. Another case in BCC. Now we are going to the radius of the niobium. So radius R. And how to calculate the radius? So in the BCC, if you know the S length, okay, I think you know. So if you know the S length, we can calculate the radius of the niobium atoms. So what is the relation between this? So I think you remember it. The relation is, so what is the relation of this? So how to calculate that is, see, I just remember, okay, 4R is equal to root 3A. That is the relation. So if we are going to calculate the R is equal to root 3A divided by 4. If you know the A, so we can calculate the radius. So how to calculate the A from the given dimension and parameter? So now here Z values we know. What is the Z value? 2. And what is the molar mass? I mean atomic mass, that is the 93. So this we know it. And what is the Avogadro's number? So we know that. What is the density is given here? Density is given here. So then first we can calculate the AQ. So how to calculate? Then let me start it. Now here. So these things are given. What are given here? What are given? Number one, density. How much? 855 gram per centimeter cube. And what is the molar mass or atomic mass of the niobium? That is a 93. So U means atomic mass unit. So we can convert it into the grams per mole. We can write in more convenient. Then now, what is the number of atom per unit cell in BCC? That is the Z. What is the Z value? 2. That is for the BCC. Then now, here we are going to calculate the A. What is the A? A is the S length. If you can calculate the S length, we can just find out the radius of the niobium easily. Then what is the formula? Formula is here. We have what we have, that is density is equal to Z into molar mass divided by AQ into MA. Now here, so how do we calculate? First we just calculate AQ. AQ is equal to Z into M divided by D into NA. So now here we can put the value 2 and we can put the value 93 and divided by, what is the density here? Density, that is 8.55. 8.55. So here is the gram per centimeter cube. Then this one is the grams per mole. And now then another is Avogadro's number, 6.022 into 10 to the power 23. This also per mole. Now here this units can be cancelled here, this can be cancelled, this can be cancelled, and this gram also will cancel, this gram also will cancel. So the per centimeter cube will remain. So when we do the calculation, what will be the answer we found here? So after you multiply this, I think you can find the 186. This is the right. Then after you do the calculation this, what will be the answer found here? So 51 point. So I took the only rounding of 5 into 10 to the power 23. Now it's remain here centimeter inverse cube. Then when we do just wait. When we do here, so when we do the calculation, that is the 3.6 into 10 to the power minus 23. When we bring here, that will be centimeter cube. And now, then after we calculate, then this decimal place can bring here, then will be 36 into 10 to the power minus 24 centimeter inverse cube. Now, what we are going to find out, that is the A. So when we do the calculation, A cube means A is equal to 36 into 10 to the power minus 24. So that is the root cube. That is what I am right. 1 by 3. And another one is centimeter cube. That also will be root cube. So this 3 cancel will be remain here centimeter. And now when we do the calculation, I mean root cube, that what values, so that is how much we found here, 3.3 something we can find, root cube 36, that is 3.3 into 10 to the power 24 divided by 3, that is minus 8. So this is centimeter. Now so this centimeter, let me convert it into the smallest unit, so that means 1 picometer is equal to 10 to the power minus 10. So let me convert it into 10 to the power minus 10. So if when we bring the 1 2, that means 330 into 10 to the power minus 10 centimeter. So we can write 330 picometer, because 1 picometer is the 10 to the power minus 10 centimeter. Right. So this is the A. If you know the A value, so how to calculate the radius of the niobium? As I said before, the relation between A, that means S line, and R is the radius. So what was the relation? That was R is equal to root 3 A divided by 4. What is the root 3 value? As you know, root 3 value 1.732. So when we do the multiply the 1.732, and what is the A value? That is the 330 and divided by 4, and units will be picometer. When we do the calculation R, so what will be the answer found here? That is, I think, 142 picometer. That is the answer. So you just remember how do we calculate and what concept we applied here. So I think it should be very helpful to you. Keep it remember. Okay then.